Okay, Jack, welcome home. Sounds like you're here in Albert Lee. Okay, but you need a break. It's been tough laying on the beach. When you come back, we want treats, right, guys? Treats and money. Treats and money. Actually, we'll give you an option. Okay, you can bring treats or money, but if it's money, minimum of $50 a person. If it's treats, minimum of 9 by 13 pan per person. And Karina has nothing to say to you. She would rather do mathematics. So here we go. All right, flip the page over. Let's apply. This is known as the power rule. And it's pretty cool. Can you find the derivative of 5? What's the derivative of 5? 0. What's the derivative of negative 8? 0. What's the derivative of 4x? 4. Now, I'm going to write this out once, and I'll never do it again so that you can see why this works out with the power rule. It's 5 times x to the 0 power. What's anything to the 0 power? 1. So if you use the power rule to find the derivative, you bring the 0 in front times 5x to the negative 1. Well, 0 times anything is 0. So that's why the power rule works for a constant. For something like this, you have 4x to the first power. So when you bring the 1 in front, you get x to the 0. So it's 1 times 4 times 1, which is 4. So you can see the power rule is at work in these examples as well. The derivative for d, negative 3. Derivative of 5x squared, 10 x to the this is a line. It has a constant rate of change of negative 3. The derivative of negative 3x is negative 3. The derivative of 5 is 0. I take the 2, I move it out front. 2 times 5 is 10. I reduce the exponent by 1. So you get x to the first plus 10, derivative of negative 3, 0. So the derivative of 5x squared plus 10x minus 3 is 10x plus 10. Do you guys have your assignment from yesterday? Take that out and look at it. Look at the first 5 problems. And check them to see if they're right. The first one says y is equal to negative 2x plus 5. What should the derivative be? Negative 2. Second one is y equals 3 plus 4x. Derivative should be 4. Number 3, what should be the derivative of x squared minus 6x? 2x minus 6. For number 4, what should be the derivative of x to the 5th? 5x to the 4th. And if you look at number 5, 4x to the 3rd plus x squared minus 2x minus 3. Drop the 3 in front, you get 12x squared plus 2x minus 2. So you should be able to use the power rule in order to simply just check your answers. If, no, because it's the power rule and problems 11, 12, and 13 are not written as a power. They're written as fractions, aren't they? Doesn't work. Excellent question. Do we have to use a shortcut? Try to do this without the shortcut. f prime of x is, what's the derivative of 2x to the 7th? 14x to the 6th minus 18x to the 5th plus 10x to the 4th what's the derivative of a constant? 0. It doesn't matter that it's 1,943,789,432. Yeah, that just changes the placement of the graph. The question? No? Okay, let's try some. So it should connect with letter K right here. You guys should see that the derivative of this is that. All we're doing is taking the exponent, multiplying in front, and we're reducing the exponent by 1. That's all that's happening. So we're going to continue to practice that. We're going to practice with problems that are a little bit more challenging. So let's look at f. First thing I need to do is I need to rewrite the function so that it has exponents. 8x to the 5th minus 3x to the 3rd plus, how do I rewrite 1 over x squared? X to the negative 2 minus x to the 1/2. Many years I've gone through, some people say, can we please do a review of exponents and positive negatives? No, no. You had that. Algebra 1, Algebra 2, college algebra. We're not going to spend 2 days reviewing what to do with positive and negative exponents. You got to follow along, pick up with what we're doing here. F prime of x is equal to, what's the derivative? 40x to the 4th minus 9x squared minus 2x to the, what's negative 2 minus 1? Negative 3. Minus 1/2 x to the negative 1/2. I cannot leave negative exponents. So therefore, I must rewrite it without negative exponents. 40 x to the 4th minus 9x squared minus 2 over x to the 3rd minus 1 over 2 roots of x. Before you suggest that that's a challenging problem, consider doing that with the formal definition of the derivative. Limit as h goes 0 of f of x plus h minus f of x over h. That would be absurd, folks. Right? So thank you, Mr. Shortcut Rule. All right, next one, f of x is equal to, I have a negative 3 and then x to what power? Is the x in the numerator or the denominator? So I'm going to have a negative, and then what's the power going to be? 5 over 3. Thank you. So Allison sees the 5 stays in the numerator, and it's the index that goes in the denominator. Now I could take the derivative. F prime of x is equal to negative 5/3 times negative 3 x to the, subtract 1, and we get negative 5/3 minus 3/3, negative 8/3. You were focusing on the front, Hannah. We were still subtracting 1 from the exponent. So I brought the negative 5/3 up front, and then negative 5/3 minus 3/3 is negative 8/3. So f prime of x is, what happens to the negatives? They go away. 3 over 3 goes away. I have 5x to the negative 8/3. I can't leave a negative, so I write this as 5 over x to the 8/3. If you are going to suggest that you have to write this as a radical, go ahead. 5 over the cubed root of x to the 8th. But this is not correct. Does anybody know why? You can have a radical in the denominator so long as it's a variable. But you can reduce the cubed root of x to the 8th, can't you? You can take a perfect cube out of x to the 6th. So if you want to write it as a radical, you're going to have to take out that perfect cube. Just leave it like that. Leave it with the rational exponent. Yes. Two x to the 1/2. Sure. The book and myself will most often write a square root if it's x to the 1/2. If it's anything else, generally speaking, rational exponent. Okay, h. Do I need to rewrite it? No. I can simply bring the exponent in front, 6 over 7 times negative 2 over 5, x to the what? Negative 1/7. Thank you. Six times negative 2. And the denominator I have 35. And then x to the 1/7. Go. 6/7 minus 1 is negative 1/7. Okay, for I have to rewrite this. Negative parentheses, 1/3 to the negative 2, x to the negative 2. I take both of those to the negative 2 power. What is 1/3 to the negative 2? What's 1/3 to the negative 1? 3. Then square it, you get 9. So you have a negative out front, so it's a negative 9. You have x to the negative 2. So what's the derivative? Negative 2 in front. Subtract 1. We rewrote the original function. We did not take the derivative till here. So a lot of times we need to rewrite the function before we take the derivative. Okay, last one, J. I have the square root of 5. This is going to be times x to the 1/2. I could separate square roots, right? So now this is my coefficient, and this is my power. So I did that. Minus, the square root of 3 is just a number, correct? What's the derivative of a constant? So I don't need to worry about this, right? Common mistake is that people write 3 to the 1/2. They'll go, okay, 1/2, 3 to the negative 1/2. So 1 over 3 roots of cube root of 3. No, no, don't do that. The derivative of the square root of 3 is 0. So we won't worry about that. It'll just go away. And then this is x to the 1/2. So all I've done is I've rewritten it. I have not taken the derivative. Now I will take the derivative. What do we get here? What's on? I got 1/2 times the square root of 5 times x to the what power? Negative 1/2. What's the derivative of the square root of 3? 0. What's the derivative of x to the 1/2? 1/2 x to the negative 1/2. Good. I don't want negative exponents. What's in the numerator? Square root of 5 over what's in the denominator? 2 roots of x. Right? X to the negative 1/2 is 1 over the square root of x. The 2 is in the denominator. Square root of 5 is in the numerator. Plus 1 is in the numerator here. And then 2 roots of x is in the denominator. Do those have the same denominator? Yeah, so I'm just going to combine them together. Get square root of 5 plus 1 over 2 roots of x. That's that. Worksheet is your assignment.